Hi, welcome to Physics Teacher. In this video I'm going to go over the solution to this problem from a grade 12 math contest that involves both trig functions and logarithms. Give it a quick try and I'll be right back with the answer. Alright, so we need to solve this system of equation for where x and y are between 0 and 180 degrees. So here we have two logarithmic functions, one where we're multiplying two trig functions and the other where we're dividing them. So let's split these up because we can use some of our logarithmic laws to do that. The first law for this first equation, where we're multiplying two functions, we can then add those logarithms. So let's rewrite equation 1 as the log in base 2 of sine x plus the log in base 2 of cos y. And that is still going to equal minus 3/2. Now I can do the same thing for equation 2. Let's call this one equation 2. When we're dividing, what we will do is subtract those log functions. So we can write it as the log in base 2 of our numerator, sine x, and then minus the log in base 2 of our denominator, cos y. And that'll still equal 1/2. Now the first thing I'm going to do then is I'm going to add those two equations. You'll notice when I add those two equations, this term, the log in base 2 of cos y, cancel. And I end up with 2 times the log of 2 of sine x is all equal to minus 3/2 plus 1/2 is just minus 1. Alright, so if I divide both sides by 2, then I end up with the log in base 2 of sine x is minus 1/2. Then I can use another property for logarithms where I take this base and use it as an exponent. So I'm left with the sine of x is equal to 2 to the power of minus 1/2. Now 2 to the power of minus 1/2 is just 1 over the square root of 2. And that's going to equal sine x. Now if you remember your special angles for the sine of something, in this case x, you'll remember that it is equal to 1 over root 2 when theta, or in this case x, is 45 degrees. But we're looking at all the values of x between 0 and 180. And if you remember your coordinates or your quadrants, right, sine is going to be positive in both quadrants 1 and 2. So we're also going to get sine x to equal 1 over root 2 when x is equal to 135 degrees. Alright, so now let's look at y. Now to look at y, we can do something similar. We'll just subtract equation 1 and 2. When I do that, the first term is going to cancel. And for the second term, I'm left with 2 times the log base 2 of cos y is equal to, so now we have minus 3/2 minus 1/2, so that's minus 2. So if I divide both sides by 2, I get the log in base 2 of cos y is equal to minus 1. And then I can do my log law where I take 2, bring it up here to get 2 to the exponent of minus 1, and that is equal to the cos of y. Now this is just 1/2. So when is the cos of a function equal to 1/2? And it turns out that that happens when y is equal to 60 degrees. And that's only going to happen once because in quadrant 2, cos is going to be negative. So therefore, all pairs where this is going to be true, all of our xy pairs, we have 2 of them. The first is going to be when x is 45 degrees and y is 60 degrees. And the second one is going to be when x is 135 degrees and y is 60 degrees.